Welcome once again. In regression chapter, we have discussed there are two regression lines. First one is x on y and second one is y on x. Later we have also discussed there are two regression coefficient also. That regression coefficient denoted by bxy and byx. To calculate the correlation, we should be having the under root of the multiplication of bxy and byx. In today's video, we will now how to calculate regression coefficient. So in today's video, I have taken the topic that is calculation of regression coefficient. How we can calculate regression coefficient bxy and byx. We are having three type of method. As in correlation we are having the method. So the very first we will discuss about the direct method of regression coefficient. Then we will discuss the assume-in method of calculating regression coefficient, etc. So as we know that regression coefficient is bxy, that is r standard deviation x upon standard deviation y. Already we know that first regression coefficient is bxy and second may be byx. So the value of bxy is r multiplied by standard deviation of x divided by standard deviation y. As we know that x on y regression equation is x minus x bar, r standard deviation of x, standard deviation y, y minus y bar. So x minus x bar, that is bxy, y minus y bar, that is x on y equation. So the bxy is equal to r multiply standard deviation x upon standard deviation y. As we know, the value of r is equal to sigma dx dy upon n guna standard deviation x guna standard deviation y. Okay. So bxy will be r, putting the value sigma dx dy upon standard deviation n multiplied by standard deviation x and standard deviation y multiplied by standard deviation x divided by standard deviation y. So standard deviation cancel to this. So the value of bxy will be sigma dx dy divided by n multiplied by standard deviation x raised to power 2. Okay. So we will having another form of this also. So now the bxy is equal to sigma dx dy upon n standard deviation x raised to power standard deviation x, not y here. Againly, first I should explain you. The value of bxy is r standard deviation x upon standard deviation y. So we are putting the value of r this. So sigma dx dy upon n standard deviation x standard deviation y, and this standard deviation x standard deviation y. We have to put the value of r standard deviation x close to this. So now this is sigma dx dy upon n multiplied by standard deviation x square and standard deviation y square. Standard deviation y is equal to sigma d square y upon n. Okay. So the square of sigma standard deviation y square will be sigma d square y divided by n, because standard deviation y square, that is sigma d square y upon n. So n to n cross. So bxy value will be sigma dx dy upon sigma d square x. That is direct method. We have to calculate bxy. Again, I am repeating the same things. I am repeating. So you may be having the perfection how to calculate value of bxy. Then we will calculate byx. Okay. First one, bxy, as you know that r standard deviation x upon standard deviation y. Value of r sigma dx dy upon n multiply standard deviation x multiply standard deviation y. So by putting the value of r in bxy, so bxy is equal to sigma dx dy divided by n standard deviation x standard deviation y multiply by standard deviation x upon standard deviation y. Both are same. So bxy is equal to sigma dx dy upon n multiply standardization of y raised to power 2. And as we know, standardization y is equal to sigma d square y upon n. So standardization y square will be sigma d square y upon n. So putting the value in this, bxy is equal to sigma dx dy upon n multiply sigma d square y upon n to n cross. So bxy will be sigma dx dy upon sigma d square y is at end, so there is y. So this is the formula of calculating bxy, that is sigma dx dy divided by sigma d square y. Similarly, we will calculate, so I am writing here bxy, that is sigma dx dy upon sigma d square y. Now sigma byx we are calculating. Step by step you will go through, easily you will get the answer. Y on x equation, that is y minus y bar, or standardization of y, standardization of x, x minus x bar, as we know that is y on x equation. So byx is equal to r standardization of y upon standardization of x, value of r is equal to sigma dx dy upon n guna standardization x guna standardization y. So by putting the value byx, that is sigma dx dy upon n standardization x standardization y multiply standardization y upon standardization x, y to y cross. So sigma yx, that is sigma dx dy upon n multiply standardization x raised to power 2. Standardization x is equal to sigma d square x upon n. So standardization x square will be sigma d square x upon n. So byx, that is sigma dx dy upon n multiply sigma d square x upon n to n cross. So byx value will be sigma dx dy upon sigma d square x. So what? Second, sigma yx is equal to sigma dx dy upon sigma d square x. In both condition, dx is equal to x minus x bar and dy is equal to y minus y bar, because both are direct method. So what you learned, bxy, you are to put sigma dx dy divided y is at last, so sigma dy square x. Sigma yx, sigma dx dy, x is last, so sigma d square x is up value. So with the help of this is the first method to calculate regression coefficient. You can calculate regression coefficient with the direct method. So you have to use that formula directly, bxy. I am writing here. Just you have to remember this formula. The trick of formula bxy, what you will do, sigma dx dy, y is here, so sigma dy square. Byx, you are to sigma dx dy, x is here, so sigma d square x. These both are the formula for the direct method. It means dx is equal to x minus actual mean and dy is equal to y minus actual mean of y. That is the first method to calculate regression coefficient bxy and byx. If assume mean method is over there, second method is assume mean method. If you are to calculate regression coefficient with assume mean method, second method, suppose we are having assume mean of x, that is x minus dx बराबर assume mean of x minus assume mean of x and dy is equal to y minus assume mean of y. It means if we are taking the deviation from assume mean, not from the real mean, we are taking the deviation from the assume mean. Sometimes the real mean are in points, so we are getting so many difficulty in calculation is over there, and at such kind of the questions we take assume mean and do the question is over there. So if assume mean is over there, bxy, that is the formula for that is n multiply by sigma dx dy minus sigma dx multiply by sigma dy divided by y is here. So n multiply by sigma d square y minus sigma dy raised to power 2. You have to use this formula and multiply by sigma dx dy. Not need to write here under root. Okay. And multiply sigma dx dy minus sigma dx multiply by sigma dy divided by n multiply sigma d square y minus sigma dy raised to power 2. Similarly, sigma yx is over there, then n sigma dx dy minus sigma dx sigma dy upper value will be same divided by n. Yeah, here x is over there, so sigma d square x minus sigma dx raised to power 2. Here dx will be x minus assumed mean of x and dy will be y minus assumed mean of y. So as far as the assumed mean is concerned, what if we have to use? Similarly, the correlation formula upper value is equal, but for y, second half of the y value will be here. So n minus sigma d square y. So for calculating bxy, you will use the formula n multiply by sigma dx dy minus sigma dx multiply by sigma dy divided by n multiply by sigma dy square minus sigma dy raised to power 2. For byx, n multiply by sigma dx dy minus sigma dx sigma multiply by sigma dy divided by n multiply by sigma d square x minus sigma dx raised to power 2. So what you have? Y is here, so y will be in downwards, x is here. In first one also there was the same method was this. So with the help of this will be the formula for calculating bxy and byx. This is direct method. Otherwise bxy we can calculate r standardization x upon standardization y. But for that we have to calculate three things. We have to calculate the value of correlation. We have to calculate the value of standard deviation of x. We have to calculate the value of standard deviation of y. To live in all this, we are having the direct formula to calculate value of bx and bxy and byx. So with the help of these formula, you can calculate the value of both the regression coefficient. Third method also for calculating regression coefficient, we are having one more method that is called direct method. Third, direct direct number method. In that bxy, we have to n multiply sigma xy minus sigma x sigma y upon n multiply sigma y square minus sigma y raised to power 2. Similarly, in this method we will not having any deviation, whether with the whether it is actual mean or assumed mean. We will not do any calculation of deviation. Direct we will get x value, x square value, y square value on multiply x and y. So putting this formula, n multiply by sigma xy minus sigma x multiply by sigma y divided by n multiply by sigma y square minus sigma y raised to power 2, we can calculate value of sigma xy. In correlation also we have learned this method. For getting byx, n multiply by xy minus sigma x multiply by sigma y, and here x, so sigma x square minus sigma x raised to power 2. Here y, so y is taken downside, x is left, x here, so this. So this is also a method for calculating a regression coefficient. You can calculate regression coefficient with any of the method, the result will be same. If numbers are very small, then this formula is very good, because you do not want bxy we can calculate n multiplied by sigma xy minus sigma x multiplied by sigma y divided by n multiplied by sigma y square minus sigma y raised to power 2. It means in this method we do not want to do anything, just we will having x value, y value will be given. We will just calculate value of x square and addition of x square. Then we will calculate y square and addition of y square, and one more things we have to do, that is the multiplication of x series and y series with the help of this. So this series is better in such kind of the case where the numbers are very small. So we are not having any problem for getting the square and getting the multiplication of x and y. So you are free to use any of this formula for calculating. I am having a practice question for that calculation of regression coefficient. Suppose our question is this, like this: value of x is given 65, 66, 67, 68, 69, 71 and 73. 1, 2, 3, 4, 5, 6, 7. No, 8 is over there. 65, 66, 67, againly 67. Then 68, 69, then 71 and 73. We will having dx y series. Okay, y series is given 67, 68, 64, 68, 72, 70, 69, and last one is 70. So this question is given, we are to calculate regression coefficient and value of x on y and y on x. For calculating, the very first we are having x bar. So for getting x bar, that is 65 plus 66 plus 67 plus 67 plus 68 plus 69 plus 71 plus 73. So total is 546. So x bar is equal to sigma x divided by n, that is 546 divided by 8, that is 68.25. For calculating y bar, we will first add 67 plus 68 plus 64 plus 68 plus 72 plus 70 plus 69 plus 70. So 548. So y bar value is sigma y upon n, that is 548 divided by 8, that is 68.5. So here we are saying that if we do with the direct method, our x bar and y bar in points is over there. So better we will use assuming method here to get the value of bxy and byx. So for getting the assuming method, suppose we have calculated 67 is assuming is 67, and assuming of y, we may be having assuming of y, we are having suppose 68. Okay, firstly we have calculated value of x bar is 68.25 and value of y bar is 68.5. so it's in point. So if we will do with the direct method, we have to do a lot of calculations. So avoiding this situation, we are having assuming method. Okay, so for assuming, suppose 67 2 times is over there, so we have taken assuming dx is equal to, if assuming of x is 67, so the value of dx will be x minus assuming of x, and value of dy will be y minus assuming of y. So 67, that is minus 2, 66 minus 67, that is minus 1. 67 minus 67, 0. 68 plus 1, that is will be plus 2. 67, that will be plus 4 and plus 6. So the result will be 10 plus 10. In this we have assumed that 68 is our assuming, so minus 1, 0, minus 4, 0, plus 4, 68, so plus 2, plus 1, plus 2. So 4 and 4, so plus 4 is over there. For checking x bar, we should calculate x bar is equal to assume mean plus sigma dx divided by n. Our assume mean is 67 plus 10 divided by 8, that is 67 plus 1.25, that is 68.25. Correct is over there. Now y bar is over there. Y bar is assume mean plus sigma dy divided by n. Assume mean we have 68 plus 4 divided by 8, so 68.5. Already y bar was this. So it means our calculation is quite right, x bar and y bar. Now we have right x bar is equal to 68.25 and y bar is equal to 68.5. Okay. Now we require d square x, d square y and dx dy. So that is 4, 1, 0, 0, 1, 4, 16, 36. 1, 0, minus 16, 0, 16, 4, 1 and 4. 2 multiply minus 1, that is plus 2. Multiply 0, 0 multiply minus 4, that is 0. 0 multiply 0, that is 0. 1 multiply 4, that is plus 4. 2 multiply 2, that is plus 4. 4 multiply 1, that is plus 4. 6 multiply 2, that is 12. So we are to calculate these all items. 4 and 1 and 4, that is 10. 26 plus 36. 26 plus 36. This value will be 62. 17 plus 20 plus 5, that is 42. 1 is 62 and 42. This is 12 and 12, 24 and 2, 26. Last value is 26. Okay. For getting bxy value, that is n multiply sigma dx dy minus sigma dx multiply sigma dy divided by n multiply sigma d square y minus sigma dy raised to power 2. That was the formula. So n value is 8, sigma dx dy, that is 26, minus sigma dx is 10, sigma dy is 4. Sigma dx 10, sigma dy is 4. 8 multiply sigma d square is 42 minus sigma y raised to power 2, that is 4. So 8 multiply 26 plus value, 46 is minus value. So 168 upper value. 8 multiply 42 plus value, 4 multiply 4 minus value, 320 is lower value. So bxy will be 168 divided by 320, that is 0.525. 0.525. And byx value, that is n multiply sigma dx dy minus sigma dx sigma dx sigma dy upon n multiply sigma d square x minus sigma dx raised to power 2. So that will be 8 multiply 26 minus 10 multiply 4 divided by 8 multiply 62 minus 10 raised to power 2. So upper value will be equal 168 divided by 62 multiplied by 8 plus value, 10 multiplied by 10 minus value, 396. So 168 divided by 396, so value will be 0.4242, 0.424. So BXY value is 0.525. BYX value, that is 0.424. So with the help of this formula, easily you can calculate the value of BXY and BYX. For BXY, n multiplied by sigma dx dy minus sigma dx multiplied by sigma dy divided by this. By putting this value, you will get 5 to 5, and for sigma BYX, you have to use that formula, that is n multiplied by sigma dx dy minus sigma dx multiplied by sigma dy divided by n multiplied by sigma d square y minus sigma dx, by putting this. Now, with the help of this, easily we can having BXY and BYX, no problem at all. One more things which we are going to discuss, that direct formula also we can check here, because we are having the facility of calculator. So X is given, Y is given. So you can having X square, you may be having Y square, you may be having XY. By putting this also, you will get the same result, BXY and BYX. Okay. So 65 multiplied by 65, that is 4225. 66 multiplied by 66, 4356. 67 multiplied by 67, that is 4489. Againly 4489. 68 multiplied by 68, that is 4624. 69 multiplied by 69, that is 4761. 71 multiplied 71, that is 5041. And 73 multiplied 73, that is 5329. So the addition of this will be 37314. Now for getting the y square value, 67 multiplied by 67, 4489. 68 multiplied by 68, that is 4624. 4624. 64 multiplied by 64, 4096. 72 multiplied by 72, 5184. 70 multiplied by 70, 4900. 69 multiplied by 69, 4761. And last one, 70 multiplied by 70, 4900. So the addition of this will be 37578. Now next, XY. 65 multiplied by 67, 4355. 66 multiplied by 68, 4488. 67 multiplied by 64, 4288. 67 multiplied by 68, 4556. 68 multiplied 72, 4896. 69 multiplied 70, 4830. 71 multiplied 69, 4899. And last one, 73 multiplied by 70, that is 5110. So the addition of this is 37422. For getting this, BXY, n multiply xy minus sigma x multiply sigma y upon n multiply sigma y square minus sigma y raised to power 2, that will be the formula. So n value is 8, multiply 37422 minus 546 multiply by 548 divided by 8 multiply sigma y 37578 minus 548 raised to power 2. By calculating this, you will get 0.525. For getting Byx, n multiply sigma xy minus sigma x sigma y divided by n multiply sigma x square minus sigma x raised to power 2. So 8 multiply 37422 minus 546 multiply 548 divided by 8 multiply 37578. This is 37314 minus 546 raised to power 2. You will get calculating this, you will get 424. So any of the formula you can use. The result will be same. Now it's very easy. X, y given, x square calculate, y square calculate, and multiplication of xy is also calculate. So for bxy we have to use this formula, and byx we have to use this formula. You will see y is here, so y is downside, x is second item, so in x is. Now calculating both regression equations. For calculating both regression equations, first is x on y, that is x minus x bar, bx by y minus y bar. So x minus 68.25, that is 0.525, y minus 68.5. So x minus 68.25, that is 0.525, y minus 68.5, 35.96. So x is equal to 0.525 y plus 35.96 plus 68.25. 32.28. So x is equal to 0.525 y plus 32 point, this is minus value, 32.28. This is x on y equation. 525 minus 32.28, or we can write 38.29. Y on x equation, y minus y bar, byx, x minus x bar. So y minus 68.5 value of y bar, 0.424, x minus 68.25. So y minus 68.5, that is 0.424 x minus 28.94. So y will be 0.424 x plus 28.94 plus 68.5. So y 424 x plus 68.5, 39.56. So with the help of this, you may directly calculate both regression coefficient bxy and byx. So I think this video will be helpful for you to know how to calculate regression coefficient with the direct method. Thank you once again. Thank you.